Limiting reactant problem. Never heard of that before. Let's go through this together. Arm in arm. Teacher and student. I don't know if we've... Arm in arm. Is that inappropriate? I don't know. Let's go on. Limiting reactant problems. Well, I know a reactant is stuff that gets used. I know limiting means like you don't have enough. Let's read on. Sometimes problem may ask you a question like which reactant will run out first? Oh my god, these questions. Or how much will actually be produced? These questions can be difficult to answer. I know. The difficulty comes from a misunderstanding about how reactions work. In chemical reactions, when the reactants make products, the reactants are both used up. That seems important. So, should be a comma there. If a chemist calculates that they need a certain amount of one reactant, they will also need a certain amount of the other reactant, assuming there is one. If the chemist does not have both reactants, the reaction will not occur. It's like if you got a recipe, A plus B equals C. If you don't have B, you can't make C. Okay? Let's look at this example. We got 8 HNO3 plus 3 copper, blah, blah, blah. Okay. If you pour 2 moles of nitric acid onto 9 moles of copper, will you use up all the copper? So this one's the nitric acid, and the copper's right here. So it's saying we have 2 of these and 9 of these. So I can already tell that, we need 8 for every 3, so we need a lot more of these, so like, no way, we don't have enough nitric acid. But let's look at what this says. To answer this question, we're going to calculate how much copper we are able to use. We know we have 9 moles, and are trying to use 9 moles, but we don't know that we have enough nitric acid to do that. So they go moles A to moles B. So they're starting with the nitric acid, they use their mole ratio, and then they get the copper. And this copper corresponds to this nitric acid. So essentially, it's saying that 2 moles of HNO3 will use 0.75 moles of copper. So we only have 2 moles, that's only going to use 0.75. Well, there's no way we're going to use 9. So what's it say? From our calculations, we found that 2 moles of nitric acid will only use up 0.75 moles of copper. Yeah, that's what I just said. Since we're trying to use up 3 moles of copper, it's obvious that we will not use up all the copper. So sad. Those are tears. Oh well, you'll have leftover copper. Okay, well, we have some practice problems. You can give it a shot below. Get ready for class. We will do them in class, though. All right, bye-bye.